topic is benzene and aromatic hydrocarbons. Let's do some questions based on benzene. Question number 1. N-hexane is treated with some catalyst at 500 degrees centigrade temperature and high pressure. You get benzene. From N-hexane you are getting benzene. Option 1, AlCl3 and HCl. Option 2, nickel and hydrogen. Option 3, Cr2O3, Al2O3, and option 4 is zinc oxide. See, this reaction is aromatization reaction, and the catalyst used in aromatization reaction is chromic oxide alumina mixture. So the correct answer is third option. The reaction is called as reforming, also called as aromatization. So for question number 1, N-hexane when it is treated with Cr2O3 and Al2O3 around 500 degrees Celsius, you get benzene. This is called as aromatization, also called as reforming. So the correct answer is option 3. Question number 2. Which of the following compounds exhibit carcinogenicity? Option 1, benzene. Option 2, ethene. 1,3 benzanthracene and 1,2 benzopyrene. See, aromatic compounds, aromatic hydrocarbons are carcinogenic substances. So among the compounds A, B, C, D, benzene, benzanthracene and benzopyrene are aromatic hydrocarbons. So these substances are expected to be carcinogenic. Carcinogenic means cancer causing substances. Aromatic hydrocarbons are doubtful substances that they may cause cancer. So the correct answer must be A, C and D. So fourth option can be taken as the correct answer, A, C, D. Question number 3. Which of the following is less reactive than benzene? A, toluene. B, chlorobenzene. C, nitrobenzene. And D, benzoic acid. Type of reaction benzene undergoes is electrophilic substitution. So we have to find out which of these is less reactive than benzene towards electrophilic substitution. I'll write down the structures. This is toluene. Next, chlorobenzene. Then you have nitrobenzene. Benzoic acid. See, benzene substituted with electron withdrawing groups will be less reactive than benzene. So this is electron withdrawing, this is electron withdrawing, this is also electron withdrawing group. Here minus I effect dominates over its plus M effect. Here this is both minus I and these two are minus I and minus M groups, so they are withdrawing groups. Whereas this will activate benzene through hyperconjugation. So the correct answer should be B, C, D, and second option is the answer, B, C, D. Chlorobenzene, nitrobenzene and benzoic acid are less reactive than benzene towards electrophilic substitution because they are electron withdrawing groups. Question number 4. Benzene is made to react with some reagent and it gives 1,4-hexadiene. The reagent is option 1, nickel hydrogen. Option 2, alcoholic KOH. Option 3, sodium liquid ammonia. And option 4 is zinc amalgam HCl. See, this is a case of 1,4 reduction. This is benzene, sodium, liquid ammonia, and you get this. This is the substance formed, 1,4-hexadiene. It's a case of 1,4 reduction. This reduction is called as Wirth reduction. Here sodium acts as a source of electron and ammonia acts as a source of H+. So 1,4 reduction takes place. Correct answer therefore is third option, sodium liquid ammonia. Question number 5. The electrophile in nitration mixture is option 1 NO2 dot, option 2 NO2 plus, option 3 NO plus, and option 4 is NO dot. And the correct answer is NO2 plus, second option. This happens like this. HNO3, when it reacts with concentrated sulfuric acid, proton transfer takes place from sulfuric acid to nitric acid and get protonated nitric acid. Then this will lose water and produces NO2 plus. This NO2 plus attacks benzene, nitronium ion. It is called as nitronium ion. This attacks as electrophile and knocks out H plus to give nitrobenzene. So the correct answer therefore is second option, nitronium ion. Question number 6. The electrophile in Friedel-Crafts alkylation is electrophile in the Friedel-Crafts alkylation. First option is R plus, second option is RCO plus, third option is RCOO plus, and fourth option is RCO dot. This is how it takes place. RCl reacts with AlCl3 and get R plus and AlCl4 minus, and the benzene ring will be attacked by R plus and get alkyl benzene. H plus is knocked out. This H plus will then regenerate AlCl3 like this. It is lost as HCl. This reaction is called as Friedel-Crafts alkylation. So the electrophile is R plus. This is the electrophile, alkyl carbocation, and the correct answer is R plus. Question number 7. This is a non-benzenoid aromatic. A. Naphthalene, B. Cyclopentadienyl anion, cycloheptatetraenyl cation, anthracene. These are the 4 compounds given, and you are asked to find out non-benzenoid aromatic. Non-benzenoid aromatic is a aromatic hydrocarbon in which you have any ring other than 6-membered ring. This is naphthalene. Naphthalene has both 6-membered rings. Therefore, naphthalene is ruled out. It is a benzenoid hydrocarbon, aromatic hydrocarbon. Cyclopentadienyl anion. This is cyclopentadienyl anion. It has 6 pi electrons. It's a 4n plus 2 system. Therefore aromatic. Then cycloheptatetraenyl cation. This also has 6 pi electrons and aromatic. And the last option is anthracene. This is also benzenoid. So these two are non-benzenoid aromatic hydrocarbons. So the answer is BC, second option. Question number 8. An aromatic compound should have A. 4n plus 2 pi electrons, B. Planar and cyclic system, C. sp3 hybridization, D. Conjugation. It should have 4n plus 2 pi electrons, it should be planar and cyclic system, and it should have conjugation. So the answer is first option. These are the three conditions required for Huckel's rule. So if these system conditions are satisfied, then the substance is Huckel aromatic. So answer is first option. Question number 9. These groups activate benzene ring for further substitution. Further substitution means electrophilic substitution. A. NH2, B. OH, C. CH3 and D. NO2. NH2 group is a plus M group. It activates. OH group is also plus M group. It also activates. C. CH3. This is hyperconjugation. It offers hyperconjugation. And D. NO2. NO2 is a minus M group. So this is a deactivating group. Therefore, correct answer is ABC, first option. These are the three groups which activate benzene towards further substitution. Question number 10. Which of the following groups are deactivating but ortho-para-directing? A. Cl, B. Br, C. CH3 and D. OCH3. You have to find out. Actually, all the groups are ortho-para-directing groups because all of them are plus M groups. Plus M groups are ortho-para-director. But then out of these, Cl and Br, their minus I effect dominates over their plus M effect. So they are deactivating but ortho-para-directing. Cl and Br. These two are plus M and minus I. Minus I dominates. Therefore, they are deactivating. Because of plus M, ortho-para-directors. So the correct answer is first option, AB. Question number 11. Meta-directing groups displace electron density from ortho-para position due to their. See, meta-directing groups are minus M groups, plus M groups are ortho-para-directors and minus M groups are meta-directors. So minus M effect is one reason, minus I effect, these two are the reasons for displacement of electron density from ortho-para position. So the correct answer is first option, AB. The minus M effect and minus I effect will cause displacement of electron density from ortho-para position. First option. Question number 12. In Friedel-Crafts acylation, benzene reacts with these compounds in the presence of AlCl3 to get ketones. First, I'll write a generalized expression for Friedel-Crafts acylation. Here, we use benzene and either we use RCOCl or anhydride. In presence of AlCl3, it will give aryl alkyl ketone of this type. So the correct answer is CD, that is third option, CD. Question number 13. Which of the following compounds undergo nitration at meta position? Option A, CCl3, option B, OCH3, option C, NH2, option D is CH3 substituted benzene. Option A, CCl3. This causes negative hyperconjugation and therefore it is a meta-director. Meta-director. B, OCH3. OP director, ortho-para director. Aniline. Aniline under the reaction conditions becomes NH3 plus and therefore meta-director. toluene, this CH3 group will exert hyperconjugation, plus hyperconjugation, therefore orthopara directed. So, the correct answer is AC, third option, AC. Question number 14, assertion, benzene reacts with N-propyl chloride in the presence of anhydrous AlCl3 to get isopropyl benzene. Reason, primary carbocation rearranges to secondary carbocation which is more stable. Let us look at the reaction. Benzene, N-propyl chloride. AlCl3, you get isopropyl benzene, and we need to find out how it happens. The N-propyl chloride reacts with AlCl3 and get AlCl4 minus and N-propyl carbocation. Then this will undergo hydride shift to give isopropyl carbocation. This will attack benzene. So, you can see the reason once again, primary carbocation rearranges to secondary carbocation which is more stable. This is primary and this is secondary. Therefore, correct answer is first option. Question number 15. In the list 1, you have nature of various groups mentioned, and in the list 2, you have the list of groups of a particular category. So, let us try to match them. First category which is mentioned in the option A is orthopara directing group, but and strongly activating groups. So, if you search from the list 2, you will realize that option 4 is more suitable for this. NH2, NR2 and OH, these are orthopara directing and they are strongly activating groups because of plus M effect. B, you have orthopara directing but weakly activating groups. Alkyl groups belong to this category because they activate due to hyperconjugation. Option C, orthopara directing but moderately activating groups. In this we can put second option, that is ester group and aminoacetyl group. So, you can put these groups because I will explain you. NHCOCH3, in this group the lone pair present on nitrogen can be released in this direction as well as in this direction. So, the release is possible in two competing directions. So, the extent of release in a particular direction will be less, that makes it moderately activating. In a similar manner, you can explain ester group. Here also, the lone pair present on this will be released in two competing directions, and that is the reason it becomes a moderately activating group. Had it been in one particular direction, then it would have been strongly activating. Because it is taking place in two competing directions, it is moderately activating. So, OCOCH3 and NHCOCH3 are moderately activating groups. CH3, C2H5 and C6H5 are weakly activating groups because they activate through hyperconjugation. NH2, NR2 and OH are strongly activating because they activate through plus M effect. Whereas, orthopara directing but weakly deactivating groups are halogens because their minus I dominates over plus M. So, the correct answer therefore is second option. Question number 16. In the list 1, you have various transformations mentioned, and in the list 2, reagents are mentioned. First transformation is phenol to benzene. Phenol to benzene. This is a case of reduction or deoxygenation, and this can be affected by this can be brought about by using zinc dust. Zinc traps oxygen and becomes zinc oxide. So, phenol is reduced to benzene by distilling it with zinc dust. So, A can be matched with fourth option. Sodium benzoate to benzene. This is sodium benzoate. This can be transformed into benzene, and we need to do decarboxylation. Soda lime is used for this purpose, so it should be matched with 3 soda lime. Next, acetylene to benzene. 3 moles of acetylene when passed through red hot copper tube, you get benzene. And then N-hexane to benzene. As I told you, this is a reforming reaction, aromatization, also called as reforming. For this we need Cr2O3 Al2O3 mixture around 500 degrees Celsius temperature. Therefore, the correct answer is third option. Question number 17. Which compounds form meta-nitro derivative? Option 1, toluene. Option 2, phenol. Option 3, ethyl benzene. And option 4, 1,1,1-trichlorotoluene. You can simply say trichlorotoluene. So the correct answer is fourth option. This is a meta-directing group minus hyperconjugation, therefore meta-director. It's a meta-director. When this is made to react with nitric acid and sulfuric acid mixture, which is called as nitrating mixture, it gives rise to meta-nitro product. So the answer is fourth option. Question number 18. Order of reactivity of benzene, toluene, anisole, chlorobenzene is. Let's write the structures and then we realize what is the order of reactivity. Chlorobenzene, it's a weakly deactivating. Chlorine is weakly deactivating. Reason is minus I dominates over plus F. Then you have, after chlorobenzene, you have toluene. This is weakly activating. Then you have anisole. This is strongly activating. Reason is plus M effect. And then you have chlorobenzene. Chlorobenzene is done. Then benzene. Here we don't have a substituent. Now the order will be like this. Anisole, which has a strongly activating group, is greater than toluene. This is greater than benzene, and comes chlorobenzene. Therefore, the correct answer is second option. Chlorobenzene less than benzene, benzene less than toluene, toluene less than anisole. Question number 19. Benzene plus chlorine in presence of ultraviolet light gives compound X. What is X? We have to find out. Option 1 is chlorobenzene. Option 2 is orthodichlorobenzene. Option 3 is C6H6Cl6, that is gamaxine. Option 4 is paradichlorobenzene. What happens is benzene adds on 3 moles of chlorine in presence of ultraviolet light. This is the substance. C6H6Cl6. It is called as gamaxine. or lindane. It is also sometimes called as 666. The correct answer is gemaxine. With this, we have come to an end of about questions, multiple choice questions on benzene. Thank you.